From set, we move to a Venn diagram. Now let's begin. So set is a collection of a well-defined objects. Set is a collection of a well-defined object. So if the object is not really defined, then you can call it a set. So what I'm trying to say is, now if I say set A, that means set is denoted with a capital letter, and the symbol we use to write it, call it a curly bracket, something like this. If I say set A, now if the definition of the set is not well defined, I can't call it a set. So what I'm trying to say, I will say, if I say set A is a four-sided shape. So this thing is well defined, four-sided shape. So I can list that set as one. Rectangle is four-sided. Square is four-sided. Trapezium is four-sided. Parallelogram. Now, I can list all these elements because I know that the definition for that set A is a four-sided shape. It's a well-defined object. Or if I say a set B is even numbers. So it's easily stated. It's even number. I can say 2, 4, 6, and it's continuing like that. So if a set is not well defined, don't call it a set. So a set is a collection of well-defined objects. Now there are something, don't forget this, we call it a curly bracket. And this, inside this curly bracket, that's what we call an element of a set. Or some they call it a member. It's an element of set B. A set is denoted with a capital letter. We have it inside the curly bracket. And what we have inside that curly bracket is what we call an element of a set. An element of a set. So let's look at the various type of sets that we have. Now, if you know the element of a set, the second thing that we have to say, there is something called a cardinality of a set. What we are trying to say about the cardinality is, if you have a set A and I list the element as 1, 2, 3, 4, 5, don't forget what is inside is what we call the element. That means the cardinality of A means this is how it is written. Right? Small n into bracket A. That's what we call cardinality of A. Small n into bracket A means that we count the number of elements. If you see we have 5 elements here, 1, 2, 3, 4, 5. I say the cardinality of set A is 5. That's what we mean by cardinality of a set. Now, let's move to types of sets. The first one I'll give you, everybody is a finite set. That means a finite set has said that the element is with end. That means the element of that set, we know the end of the element of that set. What am I saying? If I say set A is even numbers between 1 and 10. Even numbers between 1 and 10. That means I can take 2, 4, 6, 8 between. You see, this is just 4 elements. So if you can count the element of that set, you can also call it a finite set. The second one, you see an infinite set. Infinite set has said that we can't list all the elements. We cannot finish listing all the elements. For example, now, let's use, if I say a set is even numbers. Even numbers. That means this set does not have an end. Because even numbers, we have thousands of them. You can start with 2, 4, 6, 8, and we continue. You see, when you have this dot, dot, dot at the end of some elements in a set, this shows that it does not have an end. That means it's a finite set. It does not have an end. That means it's a finite set. Sometimes you can see the dot also in a finite set, but you don't see it in this form. If I want to write something in a finite set, now let me say 1, 2. If the set is integers from 1 to 10, let me say set B is integer from 1 to 10. If I want to list that element, I can list it 1, 2, 3, 4. Because I don't want to write everything, I can write 1 dash 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 or dash dot dot 10. This does not show that it is infinite. It's still finite because we still have an element at the end. Yeah, but when we are coming to infinite, there will be no elements at the end. So let's look at another thing. We call it empty sets. Empty, or we call it null set. An empty set is a set that doesn't have any elements. There's no elements in that set. If I say A, and I just put it like this, or you have a set and you see this sign, it's telling you it's an empty set, no elements inside that set. That's the meaning of an empty set. Another type of set, you like to check is what we call, is it a type of set now? There is something we call a subset. A subset, we have equivalent sets, we have equality of sets, like that. When we say a subset, anytime you see it from the word sub, that means it's a small part of a bigger something. When you say a sub, the small part of a bigger something. So when you're talking about a subset, that means you're having two sets. For example, let me say set A is 1, 2, 3, 4, 5, and B is 3, 4, 5. Now we can say B is a subset of A because all the elements in B are in A. That's the mean. B is a subset of A because all the elements in B are in A, not some now, because all the elements in B are in set A. You can say 3, 4, 5, we have that element there. So we can say B is a subset of A, but we cannot say it's a subset of B because there are some elements in A that are not in B. And this is how we write the symbol. We say B is a subset, it's a symbol for a subset. A. B is a subset of A. That means B is contained in A. Another way to put it is B is contained in A. If you want to represent it in front of diagram, I have small circle. We say that's B. I have a big circle, and that will be A. See, B is in A. That's the meaning of a subset. Now, when we say equivalent sets, this also we are checking if two sets is equivalent. It's different from equality of sets. Now, two sets are equivalent if their cardinality is the same. Two sets are equivalent if set A, if n of A is equal to n of B. Sets equivalent. That means the cardinality of set A is equal to the cardinality of set B. So the two sets are equivalent. What am I saying? If set A is 1, 2, 3, 4, and set B is A, B, C, D. If you look here, the cardinality of A, because how many elements is there? We have 4. And if you look at B, the cardinality of B, how many elements? We have 4. So set A is equivalent to B. But there's a difference when we say equality of sets. They are different. Equality of sets means those sets have the same elements. That's what we mean by equality of sets. That means the two sets we are comparing, they have the same elements. If I say, for example, set A is 1, 2, 3, and set B is 3, 1, 2. Doesn't matter how we arrange it, set A is equal to set B. Why? Because they have the same elements. They have the same elements. They have the same elements. Now let's go to some notations in sets. There's something we call, need to know some notations. This symbol is what we call a universal set. A universal set is a set that contains everything that we are considering, just like the mother of all sets. And like this is what we call intersection. It's a symbol for intersection. And when you have U, it's a symbol for union. And sometimes you have a set. That means if we say A and B, what I'm saying is A intersection B. A intersection B. And what does that mean is we are looking for the element that are common in both A and B. Both A and B. Intersection means element that are common to set A and set B. Now if set A is 4, 6, 8, 10, and set B is 2, 6, 7, 10. So A intersection B means that the element that are common. If you look at this now, we have 6 here, we have 6 here, they are common, and we have 10. So it's those two elements that are common. So A set A and set B. So intersection is telling us that elements that are common to both sets. But when we are talking about union now, derive A union B. Now, A union B means you combine the two sets, the two elements. That means combine both the elements of A and B. And if any element now occur twice, just write it once. What am I saying? If you look at the elements A and B, just like I'm joining them and bringing them together, that's the meaning of union. And we have 2. See that we have 6 is in both, so I pick 1. That's 6. I have 7. I have 8. 10 is in both, so I pick 1. So this gives me the union of A and B. Union means you are bringing together. You are combining the elements of the two sets given to you. You are combining the elements of the two sets. There is something we call a complement of a set. There's something complement of a set. This is how you generate it. You see A and you see A prime. like a 1, call it prime. That's what it denotes as complement of a set. But when you are considering complement of a set, that means you must be given a universal set. So the complement of a set are the sets in which the element is removed from the universal set, and you write out the remaining elements in the universal set. What am I trying to say? A complement of a set is they are the sets that are in the universal set, but not in set A. Sets in the universal set, but not in set A. They are the sets in the universal set, but not in set A. Now, that's the meaning. Sets in the universal set, but sorry, the word set there should not be set. Elements in the universal set. Element in the universal set. Element in the universal set, but not in set A. Let's say, for example, we have a universal set of 1 to 10, 1, 2, 4, 5, 6, 7, 8, 9, 10. And set A are even number between that. If I say set A is even numbers. Now, once a universal set is defined, that means if you are defining any set, it has to be in accordance with that universal set. Now, what they mean here is what are the even numbers in this universal set? That's the meaning. If a universal set is given, and after that universal set, a set is defined after the universal set. Because a universal set is the mother of all sets, that means that any set that any set given after the universal set has to be a subset of that universal set. So you will define that set based on the universal set. So even numbers here now, that means you can't get even number that is outside this universal set. So what they are saying, if you want to define it based on the universal set, that means what are the even numbers in the universal set? We have 2, 4, 6, 8, 10. That's it. Now, if you're not looking for a complement, saying that there are elements that are in the universal set but not in A. In other words, remove all the elements of A from the universal. So if you take away 2, 4, 6, 8, 10, element that is left there will not be our A complement. 1, 3, 5, 7, 9. That's a complement of a set. Now, the next thing we try to look at is sometimes they can define our set or universal set in terms of algebraic inequality. For example, now, algebraic inequality. Now, what do I mean? When I say universal set is I have x such that x is an integer. Now, that's how they put it. Now, it goes 1 less than or equals to x less than or equals to 10. X is an integer. Either this one is positive integer. So what they're asking you is follow this inequality. 1 less than or equals to x less than or equals to x. You see, is equals to x. 1 equals to x. 10 also equals to x. So the element is between, that means it's 1 to 10. 1, 2, 3, 4, 5, 10. That's the meaning. Let's say, for example, another set is defined like this, that x such that x, let me put it in a better perspective. So that 1 less than x less than 10. This is different from the one. 1 is less than x. That means x is greater than 1. So you start from 2. And also less than 10. So we have 2, 3, 4, 5, 6, 7, 8, 9. Because it's less than 10. That's how we can interpret an algebraic inequality when given in a set. Now let's see a question. Look at this now. This is another symbol for our universal set. Now if you don't see it in this form, or you see it like this, we are given that x such that 1 less than or equals to x less than 12 equals to x less than or equals to 12. So for this our universal set, that means ranging from 1 to 12. That's the meaning. It's a subset, and its subset D, F, and G are given. Now let's list the element of D. We are given that x such that 2 less than x less than 8. Now look at that one. That means x is greater than 2. You start from 3, 4, 5, 6, 7, less than 8. So 8 is not part. That's the element of D. Now let's check for F. 4 less than or equals to x less than. So this one is from 4 to 10. 4, 5, 6, 7, 8, 9, 10. And our G, see 1 less than x, or x less than or equals to 2. X is greater than 1. To start from 2, 3, 4. Because it's less than or equals to 4. So those are the elements of D, F, and G. D, F, and G. So the first question says if I D union F, that means we should combine both the element of D and F. If you look at the element of D here, 3, 4, 5, 6, and the element of F, 3, We have 4, 5, 6, 7. So if you start, we start 3, 4 is in the goat, so we pick 1. 5 is also there, we pick 1. 6 is there, we pick 1. 7 is there, pick 1. 8, 9, 10. That's the name. And B, say D intersection F. What is common to both D and F? So what's common? What are the elements that are common? We have 4, 5, 6, 7. That's 4, 5, 6, and 7. Now you see the third one there, that's G complement. That means we remove the element of G from the universal and we write out the rest. Or we say that element that are in the universal but not in G. Say we have 2, 3, 4. If you remove 2, 3, 4. So that means the element of G prime will be 1, 5, 6, 7, 8, 9, 10, 11, 12. And the last one is say D intersection G prime. That means we need to find D intersection G before we look for the prime. Now, what's common between set D and G? D and G. You see that's 3 and 4. 3, 4. So if you now remove 3, D intersection G 4 prime, say remove 3 and 4 from the